All right, so guys, like I said, we'll get back to example number 2. But today we want to talk about the half-angle formulas. So, half-angle formulas, here they are in all their glory, right? These are the half-angle formulas. So just like the sum and difference formulas, just like the double-angle formulas, you are not going to be expected to have these memorized. You are going to be expected to know how to apply them. Not, are you walking into tests, the test on Friday or whenever it happens. You're not going to walk into to the test and have to have this memorized. Like I said, you're going to receive a formula sheet that will have those, again, half-angle formulas, double-angle formulas, sum and difference formulas. You'll be given those. Now, your other identities, fundamental identities, yeah, we need to walk in on test day knowing how those things work. So, a couple of people have already asked if we were to have a snow day tomorrow. Then yes, test is going to be floated to Tuesday, sorry. So, again, that's not ideal, got to be honest with you. Again, when we test on a Monday or Tuesday after a break, that always makes me a little nervous. Again, part of me wants to say, well, in theory, we're just giving you more time to prepare, but realistically, we're giving you more time to forget stuff since we actually did the review. So again, I do go back and forth on it, but I also don't want really to, if we have a snow day tomorrow, I don't know, I would still like to put some finishing touches on some things, and that's really what Friday would be about. You guys know how I feel about the around the room activity, or review activities. I think it really helps. I think that, like I said, is where this stuff comes together a lot. So again, we want to make sure that we have the opportunity to do that. Now, again, if we're in school tomorrow, if we're going to review tomorrow, we'll be ready to go on Friday. If we're not in school tomorrow, we're going to review Friday, and I know that's a little weird that we review Friday and we don't test until Tuesday, but again, that's the hand that we're dealt at that point. So, again, hopefully that's something that we have to mess with, I guess. I don't know. Everybody likes snow days, including me. But, again, we'll handle that should we need to handle that. I'm confident that we'll be okay. All right, so guys, when we talk about the half-angle formulas, basically what this is going to boil down to, again, you're not going to need to memorize these. We're going to need to apply them. And we're talking about the same stuff here at the end of section 5.5 that we were at the beginning of 5.5 and all throughout section 5.4. How can we find the exact values of angles that maybe are not one of the 16 that we have mastered from the unit circle? Okay, so like for instance, what if we had a I don't know, a 15-degree angle that we needed to calculate? Well, we talked about already how we could use difference formulas to get there, but is there another way? Well, what if we looked at it as, well, 15 degrees is merely half of 30 degrees, and we know an awful lot about a 30-degree angle. We could use these half-angle formulas. If I were to put a 30 in place for you, 30 over 2 is really the sine of 15 degrees, right? If we just rewrite it merely as 30 divided by 2, that is representing our 15-degree actual targeted angle. Okay? Now, are we going to use half-angle formulas for all 16? Again, like for instance, half of 90 degrees, well, that's 45. We just know how to evaluate 45. Or half of 60 is 30. We just know how to evaluate 30. So we would never use that in those cases. But what about like 22.5 degrees? That's half of 45, right? Again, so there are various times that absolutely we're going to use a half angle. There's other times that, you know what, it's probably in our best interest to go another route. All right? So if and when we need to use these half angle formulas, here they are. There are going to be a couple of things that are worth mentioning here. Like for instance, when we look at the sine of u over 2, that's equal to plus or minus the square root of 1 minus cosine u over 2. So we've seen plus or minus symbols before. We know how they work. And generally, when we talk about a plus or minus symbol being associated with a radical, with the square root, we probably don't think twice about that at all. When we find the square roots, we're going to have positive, we're going to have negatives, except for when we're talking about trig. So no, we are not actually going to have two solutions here. What we need to do is we need to look at the targeted angle. Not the one that we're pulling off of the unit circle, but the targeted angle. So like I said before, if we're using 15 degrees, for instance, if we're using here in a little bit, we're going to do an example. 105 degrees. We don't know what that is on the, or that's not one of our 16 spots on the unit circle. But I know that 105 degrees is exactly half of 210. Oh, well, I know where that one is. Does that make sense? But in that particular instance, 105, that would be the targeted angle. Which quadrant is that in? 105 degree angles in quadrant 2, the second quadrant. So if you're finding the sine of 105 degrees, the sine of anything in the second quadrant, is that going to be positive or negative? It's going to be positive. So that's how we're going to determine our sine. Notice the same thing's happening over here with cosine. Okay? Let's use 105 again. Cosine of 105 degrees, second quadrant still. Where's is cosine going to be positive or negative in the second quadrant? That would be negative then. Does that make sense how we're going to get there? It's all about the targeted angle. Now, when we get down here to tangent, you'll notice that we don't have to do that. We kind of like the cosine double angle formulas where we had 3 options. Here for the tangent half angles, we have 2 options. You don't have to do both of them. It's really just going to be your call as to which one you want to use. All right? So, as a reminder, little reminder here, that the sines of sine of u over 2 and cosine of u over 2, that's going to be dependent upon which quadrant your targeted angle, your u over 2, that targeted angle lies in. So as a reminder, let's not overthink this. Let's not make it harder than it needs to be. I'm, again, hopefully not over confident that we have in our back pocket this all students take classes trick to help us get there. We could also think of it realistically as sine. Well, that's going to be positive so long as you're above the origin, negative if you're below the origin. Cosine, if you're to the right of the origin, positive, to the left of the origin, negative. And like I said, we don't have to worry about tangent. It's just about sines and cosines. Okay? Guys, do we have any questions? I know we haven't seen any problems yet, but do we have any questions about the setup and how this is structured? To me, the weirdest obstacle to overcome is the whole, okay, so it's a positive, negative, but I only keep one of them? Absolutely. I think we just need to see it a couple of times. All right? Dea. Mm-hmm. Correct. Mm-hmm. Yep, correct. All right, so here's that exact example that we just mentioned here. If our task is to find the exact value of the sine of 105 degrees. Now, in fairness, just to be clear, because again, we're trying to prepare for a test, and we are not on a level playing field here, because I wrote the test and you haven't seen the test yet, right? So again, that's probably the biggest thing that never needed to be stated, but it just was. But if we were just asked to find the sine of 105 degrees, could we do that using sum and difference formulas? Could we do that? Again, we have options, I suppose, is how we're going to get there. So please understand that on the Chapter 5 test, whether that's Friday or Monday, when we take, or Tuesday, sorry, when we take the Chapter 5 test, that the directions will be written in a way such that it will say, using a half-angle formula, find the exact value of the sine of 105 degrees. And then the very next question might say, using a sum or difference formula, find the sine of 105 degrees. It's actually going to do that a couple of times to where it gives you the exact same, trig function that you're trying to find. But what you're going to notice is that if we did this sine of 105 using sum and difference formulas, your answer is going to look totally different than if we use half angle. They're equivalent, don't get me wrong, but they look different. Okay, it's going to be really easy for me or anybody else that is looking at these or grading these to determine, yep, you use the proper formula or you use the wrong one. Okay, so here we go. We want to find the sine of 105 degrees. Do we know the sine of 105 degrees from the unit circle? We do not. So instead, when we're trying to find the sine of 105 degrees, if that's the target, what we need to come to the realization is that, well, 105 degrees is merely half of 210 degrees. So here's what everything is going to hinge on here and now. Are these two things that I've just written up there equivalent? Is the sine of 105 going to be equal to the sine of 210 over 2? Yes, because 210 over 2 is 105 degrees. Now that we've drawn this back to a 210 degree angle, which is one of the 16 that we know from the unit circle, now we can use our formula. Does that make sense? Does everybody kind of understand and have a grasp of what it is that we're trying to pull off? Okay, so remember what we said. on the previous slide, we said that the sine of, I guess I'm using theta, sorry. So the sine of theta over 2, I've written them over here. That's going to be equal to, we say plus or minus the square root of, again, just going right over there, we've got 1 minus the cosine of u all over 2. Okay? So for our problem, we're setting this up as the sine of 210 over 2. What does that tell us? Everywhere we see a theta or a u, what are we going to put? 210? So we've got 1 minus the cosine of 210 degrees all over 2. All right, now we could make the argument that we're actually kind of sort of done with the pre-calculus. I would actually argue that we have one more step. We need to figure out, I like to do it early on. Are we going to say that this is the positive or this is the negative? I would encourage us to throw it out as soon as possible, mainly because I don't trust myself to remember to do it at the end. So what do we think? Which is the targeted angle? Is it 210? No, what was the targeted angle? I know it's not on screen here, sorry. 105 degrees. Okay, we've already answered these questions. But guys, do we understand the severity there? If we accidentally think that 210 is our target angle, that's in the third quadrant. Sine's negative in the third quadrant. We're gonna get it wrong, is what I'm saying. Okay, if we correctly identify that, yeah, sine's positive in the second quadrant, now we know that we're going to be using the positive version of that plus or minus sign. Does that make sense? Are we all good with that? Can I get like a head nod or thumbs up or something? Okay, good. All right, so the rest of this is really just cleaning up fractions and all of that fun stuff. What are you going to tell me? What is the cosine of 210 degrees, please? Negative root 3 over 2, is that what I heard? All right, and this is all over 2. So as we go to clean this up, again, we have everything is under a radical. Everything's under a radical. It's over 2. I want to actually subtract these. And actually, even before that, we all in agreement, when you subtract a negative, you're really adding. So it's really 1 plus root 3 over 2. Could I rewrite that 1 as 2 over 2 plus root 3 over 2? So now, as weird as it sounds, in the numerator, my common denominators are 2. So I've got all of this is over 2. But could we rewrite that numerator as 2 plus root 3 all over 2? You guys with me on that? Now, why am I not saying that that's like root 5 over 2 or something? Can I add 2 plus root 3? Not any more than what we just did. Okay, they're not like terms, so that's as good as it's going to get. All right, you know where I'm going with this. When you divide fractions, what are you really doing? Multiply by the reciprocal. So we've got 2 plus root 3 over 2 times the reciprocal of 2 is 1/2. And at this point, now when we multiply straight across, that's going to leave us in the numerator with 2 plus root 3 over 2 times 2 is going to be 4. All right, now technically, when we have a radical, and this whole fraction is under the radical, we could split and say that that's really looking more like this, isn't it? Now, can I do any better in the numerator? Not unless we wanted to bring in exponents and things like that, which we don't. But we can do a little bit better in the denominator. So we've got my numerator, the 2 plus root 3 all under the radical. But what are you going to tell me the square root of 4 is? It is 2. Now, usually when we find the square root of values, we have to worry about positive, negative signs, don't we? Luckily, we already figured that out. We knew going into this problem that this was only going to be the positive form. So there it is. Okay? All right, now going back to the very start of this problem. Very start of this problem. In my opinion, just one guy's humble opinion here. My opinion is that if we can recognize that 105 is actually half of 210, and then we can identify which formula to use and plug in 210 for theta or u, we got it at that point. It's correctly identifying, all right, this particular angle is half of which spot on the unit circle. And if we can do that, we're in good shape. All right, so one other thing here, because we went in degrees. What if we had radians? Is this just like the double angles? Could we switch over to degrees anytime you choose? Yeah, it's not mandatory, but again, it's not going to affect my outcome of the answer. All right? So guys, homework assignment. By the way, I'm going to go ahead and throw one more up there on the video just in case we needed to see it, but I assure you it's going to work out the exact same way. But again, your homework assignment due tomorrow on page 385.
What about that? When's that blue packet